Let's check the branch's instructions, for example, branch equal. We will compare the content of these two registers that are assigned to under our Sun1. And if the content are equal, then we will jump to one location. The opposite of the target location will be computed by adding this number by the content of the program. Content. Actually, this number also is the number of words, so it should be multiplied by 4. Then it should be added to the content of the program content. And also program counter is referred to the next instruction. So in fact, we will add this number to the program content plus 4. OK. So if this is the instruction, some part of the instructions specify this number. We will first extend it into 32 bits and then we will shift 2 times this number to the left. So it is like we multiply this number by 4, multiply by 4, and then this number will be at width. The orders of the next instruction. This value is inside the program counter. So we will by this way, we will compute the target order. This target address should be loaded into the program context. In the condition part B, read 2 registers content from the register fight and we will give it to the U and I will provide 1-0 output if these two values are equal, and if it is two values are not equal, the output of the 0 will be 0. We will give this part to the controller of logic in order to provide the other parts we can discuss about it in the near future. So now let's integrating the archetype and memory together. As you can see, the archive and load stores and instructions are very similar. Only the difference is that the second all U sources should for the hour type provided by a register. For the I type, it is an immediate data and also the write register value should be come from the ILU or from the memory. So we have two options here for the second input of the value and here for write register value for register instructions or type. It is coming from the OIL for or load word will be come from the memory. So how we can select between two different value and put it here? We should use a multiplex cell for this purpose. So we need one multiplex out here to buy one multiplex and one multiplex. We have to provide the value for writes register. It can be come from the ILO or it can be come from memory. So pay attention that each of these inputs lines are 32 bits here. All of them are 32 bits, lines, or passes. And since we want to select between two inputs. Each of these multiple accept as one line for selection. It has a one selection line. To select between one of these two inputs, consult this multiple Excel has a specific selector and the control unit to specify the value of the selection line. So now we can add this part to the top part of the data part. This is the part that we have for reading one instruction and also updating the program content. Then this 32 bits value will be given to this part. By this way, we can construct a data path for all type and type. As we said in the previous part, since we want to perform or complete each instruction in one single class, we have to use two different types of memories, one for instructions and one for data. As you can see here we have two types of the memories. We assume that all of the instructions are here and all of the data are in a separate memory. Let's add the branch data part to the previous one. As we said, for the branch instruction after we performed sign extension, we should shift the value 2 times to the left or multiply by 4, then add it with the program counter plus 4, and this value should be loaded into the program counter. So now program counter and be loaded by 2 values, 1 program counter plus 4 for regular instruction, and 1 the target address for branch instruction. So we have 1 multiplex again here, and this multiplex will select between these two sources, program content plus 4 or target outlets. As you can see, the result is a scroll back into the program. Cut. So let's see some more detail about the data part. As you remember, we use program content to fetch the next instruction from the instruction memory. And after we fetch one instruction, the program content must be incremented to the next instruction. As you know, each instruction takes 4 bytes, so we need to add 4 unit to the current value of the program content. So we have other here, and the current value of the program content will be add by 4 unit, and the result will be come back and store again in the program content. So by this way, the program content will be loaded by program content plus 4, or in fact program content refer to the next instruction. Since all of the instructions in MIPS have a fixed way wide 32 bits, so it can be easily find the address of the next instruction by adding 4 unit to the current value of the program country. So in the ART instruction we have 3 registers to register for input and 1 destination register, or SRT, that are used to provide data for the ILU, and the R, the or destination register, which receive data from the ITU. So we can give the value of the Rs and NRT into the register number A and register number of the register file. Each of these lines consist of 5 bits. Specify one register, then the register file. Give us the value of this to register. And these are 32-bit data. Oh. That should be given to the ILO and the ILO according to the instruction function part. Perform some operation over these two data and the result will be given to the right register, and it should be saved into the registered destination. So this is the registered destination or and these are the source 1 and 2 Rs and or T. For the memory operations like load word. As you see here, for example, we want to load one data from the memory and put it into the registered $91. The others of the memory will be provided by the content of the registered $S3, and it should be added by this number 450. So the effective address will be provided by adding these to number the content of the one register and the value that we provided here. So this part of the instruction is a 16-bit value. It should be extended into 32 bits because they are value only except to 32 bits value. We have to extend this number into 32-bit for this way. For this purpose we use sign extended method. If the leftmost bit of this number is 1, we put 16 in the left side and make it 32-bit. And if the sign width is 0, we put 16 in the left side and convert it into 32-bit. So one register come from the register file and this number come from the instruction part, and these two value will be given to the value. And you provide one address and we give it to the other space of the data memory and data memory. Provide the content of this memory and it will be given and we put it into the just the right register data part of the register file, and the destination value will be given by this part. For the external world, the operation is the same. We compute 1 orders of the memory, but this time the value of these registers should be saved into the memory. So as you can see, this value will be given to the database of the memory and will write data part. And this value will be stored in the memory that we specify. It's addressed by this part.